Now, in this video, we are going to take up one problem on projections of lines. The problem reads as a line capital AB, 80 mm long, has its end capital A, 20 mm above HB and 30 mm in front of VB. It is inclined at 30 degrees to HB and 45 degrees to VB. Draw the projections of the line and find its apparent length and apparent inclinations. So, this is the problem which is given to you. A line capital AB. From the introduction videos, what we have seen, a line capital AB, whenever it is denoted by capital letters, that means it is in true length. So, he has given the true length of the line, which is 80 mm long, has its end A, 20 mm above HB and 30 mm in front of VB. That is, one end point of the line of the true length is being given. Then he says it is inclined to HB and to VB. So that means the inclination, what inclination is given? The true inclination of the line, that is theta, with respect to HB is theta and with respect to VB is phi. Both theta and phi is given. Draw the projections of the line and find its apparent length and apparent inclinations. How to do that now? Now we will go to the next point. So we will going to take the three-dimensional sketch or the three-dimensional view of the object. How exactly it will going to look in three dimension, what actually the problem is given. So he says the line capital A, that is A capital A, is above HB by 20 mm and in front of VP by above HB by 20 mm and in front of VP by 30 mm. And he says the line is 80 mm long. This is 80 mm long, which is inclined at 30 degrees to HB. Okay. Similarly, a line capital AB is 80 mm long, is inclined at 45 degrees to VP. So the true length is same both in the front view as well as in the top view, always. So that according to that, when you look from the front view, what happens? The image will going to fall on the vertical plane. Which is those images which will going to fall on the vertical plane? The distance above HP, that is 20, and this capital AB, which is 80 mm. So you can see that A dash B dash is 80, A dash B1 dash is 80 mm and inclined at 30 degrees. These are the things. So once you get this line in the front view, so you are getting the boundary, that is the locus of B in the front view. So he says this is capital AB because 80 mm long. So you are writing capital A and capital B. So this is not the front view, but it is the true length of the front view. That is the reason why we are taking B1 dash. Why it is called B1 dash? Because this is the first line we are considering. So that is the reason why we have B1. Similarly, when you look from the top view, the two endpoints of the line are at equidistance from the vertical plane. So it is parallel to VP. So since it is parallel to VP, you are getting the true length. Okay. Now, when you look from the top view, the distance in front of VP is seen in HB, so that is 30. Okay. So you are getting this point. That image will go to fall here. And it is the true length in HB means what? True length should be parallel to HB. So A is above HB by 20 mm and B2 is also above HB by 20 mm. So the line is parallel to HB. Since the line is parallel to HB, so you are getting the true length in HB. What is the true length here? Capital A and capital B. Okay. The inclination made by this is 45 degree, which is already given. So I am getting this line also. So this is how I will be able to write both the top view and front view. So now when it is being rotated, you can see that first we are going to draw the XY line and we will mark HB and VP. So the distance above HP is 20 mm. So you take 20 mm here and draw a horizontal line. Similarly, from XY line, you measure 30 mm and draw a horizontal line. That is in front of VP. So we are considering any point on this line and I will draw a vertical line. So I will go to mark A dash and A. That is the top view and front view. So from A dash you will go to measure 30 degrees. You draw a horizontal inclined line. Similarly from A you measure 45 degree and draw a inclined line. Where exactly you have to take 30 degree and where exactly you have to take 45 degree? That is the next part of the question. So 30 degree is inclined to HP. So where you can see that inclination in seen. Since it is the inclination given with respect to HP, so the image will be on VP. So therefore, in vertical plane, you take 30 degrees. Similarly, inclination given with respect to VP, where you can see in HP. So from A, you measure 45 degree and draw a inclined line. Then by using the compass, since the true length is same in both in HP and VP, you measure 80 mm. With A dash as center, cut an arc on this inclined line, that is 30 degree line. And you mark this point as B1 dash. It is not the front view. Front view means A dash B dash only. But since it is the true length, because he has given in the problem, it is the true length. So you have to take B1 dash. And since he says the true length, so I will mark this as capital A and capital B. Because capital AB is 80 mm long, inclined at 30 degrees to HP. Since the true length is same in both in horizontal plane and also in the vertical plane, so take the same length of 80 with A center, cut an arc on this 45 degree line. And you mark this point as B2. And you draw the locus. And you mark this as capital A and capital B. Okay. So this is how you will be able to write the manually. Once you do that, now we will take the concept. So what is the concept? If the line has to be in true length in the front view, obviously that line should be parallel to XY line in the top view. Okay. Now, you know that the front view line is in true length, capital AB. In the top view, that line should be parallel to XY. Is the top view is written for this? No, we have not done this. Similarly, in the top view, if the line is in true length, in the front view, that line should be parallel. Apply this concept. Because he is already given in this problem, in the problem he has given, this point is given and also this point is given. That is, this point is given and this point is given. Okay. And he has given the true length here. So, apply these rules here. So, this is the true length in the horizontal plane. Means what? It should be parallel to XY line in the front view. Is it there? No. So, we have to do that. Now, what we will do? So, now we will see now. Here, since it is the true length in HP, obviously that should be parallel to HP. So, when you look from the front view, what happens? Both A and B2 are at equidistant from the horizontal plane. So, what I need to do? I need to project this point from the front view to this point. Then only that A, B2 will be parallel. Why only I need to project this till here? Because A dash is above HP by 20 mm and B2 dash should also be above HP by 20 mm only. Then only the line will be parallel to HP according to this. You can see the line is parallel to HP. You know that this line is parallel to HP because in the problem he has given this line is in true length. So therefore, when you project this point B2, that B2 dash should be in line with A dash only. So apply this rule here. So we have this line. Then you project B2. From B2 you draw a vertical projector till where? Till to the A dash line projected. So you are going to get B2 dash. So this is the top view and this will going to be the front view for this AB2. Therefore you are going to get A dash B2 dash. Similarly, you know that this is the true length in the vertical plane. Since it is the true length in the vertical plane, that means this line is parallel to VP. When you write the top view, you know that this point A is 30 mm in front of VP. Therefore, B1 should also be in front of VP by 30 mm only. Correct? So when you project the top view point, both A, small a B1, or where you have A, because this A is already fixed because it is given in the problem. But we have not been able to get the point B1 because we have not been able to get the top view point. So we have to get the top view point of the point B1. Where you will going to get? Both A and B1 are at equidistant from the vertical plane because he is already given in the problem that it has the true length. So true length in VP means what? It should be parallel to VP. So that is what, when you are projecting this point, both A and B1 are at equidistant from the vertical plane. Since A is in front of VP by 30 mm, the B1 should also be in front of VP by 30 mm. Therefore, from B1 dash, you draw a vertical projector till where? Till to the locus of A in the top view. That A is in front of VP by 30, so B1 should also be in front of VP by 30. Therefore, the line will be parallel to VP. Since this line is parallel to VP, therefore, in the front view, you are getting the true length. He is already given that it has a true length. Since it is the true length and true inclination, therefore, I will be projecting that point directly to the locus of A in the top view. So that if the top view line is parallel, correspondingly in the front view, that line is in true length. If the front view line is parallel, then correspondingly in the top view, AB2 is in true length. So you have got A dash B2 dash, and then you have got AB1. And this will going to be the locus of B in the front view, and this will going to be the locus of B in the top view. Once you get the locus of B in the top view and front view, why I should get the locus of B in the front view and top view? Because now I need to find out the front view and also in the top view. Where I have got the top view length, I have got AB1 is the top view length and A dash B2 is the A dash B2 dash is the front view. But because due to the presence of locus of B in the top view, B1 will not be in front of VP by 30 mm, but B1 will be in front of VP by this distance. Similarly, the locus of B in the front view is here, but actual point of front view is now at this point. But I have to get this point B2 should be on the locus of B in the front view here, such that without altering the length of A dash B2 dash, this length should not alter, but B2 dash should go to the locus of B. That is possible only by drawing an arc. Similarly, AB1 is the length of the front top view, but B1 should not be here. B1 should come on the locus of B, such that the length of AB1 should not alter. That means you need to rotate this till to the locus of B in the top view. So how to do that? Let us see. Now you can see here, that is what we have done. So, with A center, taking the radius of AB1, because that is the line in space, it is the true length in vertical plane. So, I am rotating such that B1 will going to cut the locus of B in the top view. So, with this as center, when you start rotating, what happens to this image you see? This vertical line is being rotated. That is from here, this being is rotated till to the locus of B in the top view. So you till here you will be able to get the rotation. So when you project that point, it will be here on the locus of B in the top view. So you got B, so join A to B with a dark line. So this will going to be the beta inclination. Similarly, so this is how we are going to get the top view line. The length of AB1 will be equal to the length of AB. That is very, very important. You cannot alter the length of the top view. We will be able to find the inclination of the top view. Why you are doing this? Because we have the locus of B here. If the locus of B wouldn't have been there, then this will going to be the top view itself. Since the presence of locus of B is in front of VP by this distance, so the B which is not in front of VP by 30, but B is in front of VP by this distance, such that the length of the line, the top view length of the line will not get altered. So that is the reason why we are rotating it by using the compass. So now that we will going to see here, the same thing what I have explained there, with A center taking the radius of AB1 by using the compass, I am rotating such that till it comes to the locus of B in the top view. So once it cuts the locus of B in the top view, you got this point, you mark this point as small b, then join A to B with a dark line. So this will going to be the apparent inclination in the top view. Now the same thing I need to do in the front view. So how to do that? Now you can see with A center taking the radius of AB2, I am rotating like this. That means the above HP by 20, now the above HP by 20 will not be above HP by 20, instead it is above HP by this distance till to the locus of B. So you observe here what happens when you look from the front view, this B2 has been projected here, okay. So as with this as center, in this as AB2 as the radius, when you are rotating in this space, what happens to that image? You can see from A dash to B2 dash, that is also being rotated till where? Till to the locus of B in the front view. When it is projected, that projection will going to come and hits here. So in other words, with A center taking the radius of AB2, you are rotating such that this B will going to touch us, the image of this B will going to touch us the locus of B line in the front view. So you mark that point as B dash, join A dash B dash with a dark line and show that notation as alpha. The length of A dash B2 dash is equal to the length of A dash B dash. So this is how you will be able to get the front view. So that is the one which we have shown here with A dash as center taking the radius of A dash B2 dash. So here A dash is 20 mm above HP, B2 dash is also above HP by 20 mm, but B2 dash is not above HP by 20 mm because the B2 dash is above HP by this distance, because due to the presence of locus of B in the front view. So with A dash center, A dash B2 dash is the radius, you draw an arc by using the compass such that it will go to cut the locus of B in the front view. And you mark this point as B dash, join A dash B dash with a dark line. So you measure this angle and you mark this point as alpha. By using the protractor, you measure this angle alpha, which will be equal to 45, and beta, which is equal to 54.74 degree, and AB will be equal to 69.28. AB means what? The length of this AB is 69.28 mm, and A dash B dash, the length of A dash B dash will be 56.57 mm. This A dash B dash is equal to A dash beta dash. This AB1 will be equal to AB. So this will going to be the final answer what we will going to get when you are doing it in computer. Even so, now we will going to analyze how I know that this problem is right. This is the last part of your analyzation. So he says the point A is above HP by 20 mm. Above HP where I should get? In VP. So you are getting in VP. In front of VP by 30 mm. In front of VP has to be seen in HP. So I will mark these 2 points as A and A dash. And he says the line is inclined to HP. Inclination with respect to HP is seen in VP. So I will draw a line here. So you have A dash B1 dash. You know that it is capital AB. Yes, 30 degrees. You know this capital AB, which is 45 degree. Okay. Now we know that this is the true length in the vertical plane. Obviously, that is in the front view, it is in true length. Then obviously that AB1 will be parallel to XY line in the top view. You know this is the true length in the HP, that is AB2. That is A dash B2 dash should be parallel to XY. You can see A dash B2 dash is parallel to XY. And you know this is the front view because the top view line is inclined. You know that this is the top view because the front view line is inclined. And when you join between B dash and B, both should lie on the same line. So this is how we will be able to say, or we will be able to tell that our problem is right. So this is how you should be able to analyze your drawing completely and follow the procedure according to the rules what we have taught in the introduction to the projections of lines. Thank you.